Hi, Algebra 2 students. All right, today in day 2, we're going to use Soh-Cah-Toa to solve for missing sides and angles in a right triangle. Keywords there, the triangles that we're going to be looking at today are all going to be right triangles, which means that we can use our ratios Soh-Cah-Toa. Just a quick refresher, So is saying that sine of my angle theta is going to be equal to the opposite side over the hypotenuse side. And cosine of theta, the Ka, is saying that that's the ratio of the adjacent side over the hypotenuse side. The Toa is saying that tangent of theta is the opposite over the adjacent side. Okay, so when I start looking at solving for an angle or a side, I want to think about which one of these trig functions is most appropriate. So what I start to do is I start to think in relation to the angle that's labeled, so this is 34 degrees, what sides do I also have labeled? So it looks like I have across from the 34 degrees labeled. I know that anything across from the angle that I'm looking at, it should be labeled as the opposite side. I do not have the hypotenuse labeled, right? The hypotenuse always goes across from the 90-degree angle, and that's not labeled on here at all, so I don't have the hypotenuse, but I do have the angle next to or adjacent, the side that's adjacent to my angle. So I have the opposite and adjacent sides labeled, which means that I want to be using this tangent function. So I'm going to set up my trig function, tangent of 34 degrees, right? So it's always the angle, tangent of my angle, is equal to the opposite side, which is labeled with an x, divided by the adjacent side, which is labeled with a 15. To solve this equation for x, I want to undo dividing by 15, so I'm going to multiply both sides by 15. And then I end up getting x is equal to 15 times the tangent of 34 degrees. And from here, this is something we can type directly into our calculators. We got to make sure our calculator is set in the correct mode. So on the Casio, the mode has to be in degrees. Okay, on the Casio, to make sure you're in the correct mode, when you're in the run matrix screen, as I am. Okay, so in general, if you were in the menu screen, then you'd go into run matrix. Then you want to hit shift and setup. That way you can see some of the different setups that your calculator has automatically placed in here. If we look down at the options for angle, mine is currently in degrees. You might see the word RAD, which stands for radians. Okay, to change it back to degrees, all you would do is hit F1, which is choosing the degree option. Okay, and then we'd want to exit out of there. So to get out of this screen, we hit shift and quit. In the TI, to get your calculator in that same setup, give me a second here, it's getting loaded. Okay, in the TI, to get your mode to be in degrees, you're going to click up mode. And then you'll see mine is currently, if I scroll down, I'm currently highlighting the word degree. Let's say that your screen looked like this, right? So you come in here and it says, ooh, radian is highlighted, okay? You want to change that into degrees, so you slide down and then highlight to the right, press the right arrow key to get degree highlighted and press enter on that. And then once degree is highlighted, you can hit second quit. Okay, now we should be good for typing this directly into our calculator. So I'm going to go ahead and work on the Casio from now on. I hit 15 tan of 34, because that's my degrees, and I press execute. I'm getting 10.12. Let's round for the sake of these problems. Let's round to the nearest hundredth. Okay, just double check on your calculator that you're getting the same thing. So 10.12 rounded should be the value of x. Now these sides aren't labeled with like inches or units at all, so we could just label it with units. If you had something like inches or centimeters, then you'd want to make sure that you labeled your side. Okay, let's try another one. So problem 3, now this one I really like. It's similar, okay, but we're going to notice the solving process is a little bit different. So when we set this triangle up again, our proportion up again, we want to think in relation to the angle. So in relation to 27 degrees, what do I have labeled? I have the opposite side labeled. And it looks like x is across from the 90 degrees, so I have the hypotenuse labeled. So then I ask myself which trig function connects the opposite and the hypotenuse sides. That's the SO, right? So sine of my angle, 27, is equal to the opposite side, which is 11, over the hypotenuse, which is x. This one is different because the x is in the denominator. So when we see that x in the denominator, the easier way to solve this is for us to just think about this as setting two proportions equal to each other, right? So I'm going to write sine of 27 over 1 because that's the same thing. And now I can go ahead and solve this by cross multiplying. So 11 times 1 is 11. That should equal x multiplied by the sine of 27. To isolate the variable x, we're going to divide both sides by sine of 27. And so our final answer should be x equals 11 divided by sine of 27. This we can type directly in our calculator. So 11 divided by sine of 27 should be 24.23. Just double check that you're getting those same numbers as we're going through this video. So 24.23 for that's hypotenuse side. And also, as I'm looking at this answer, I'm asking myself, does that make sense? If I think in relation to the other side, 24.23 is bigger than the other side, and the hypotenuse should be the biggest side of the triangle. So that does make sense to me. Okay, so we did two examples where we're finding the missing sides. Now we're going to kind of transition into finding a missing angle. It does take a little bit of a different thought process here, right? So if I wanted to solve for an angle, if I look at problem number 5, the angle is stuck. It's inside the cosine function, right? So this is saying take cosine of x, and that's equal to the ratio of 0.87. Now, I need to undo cosine, and a lot of times we want to divide, but this isn't cosine times x, this is cosine of x. So thinking about this as if, like, when we take the square root of x equals 4, right? To undo the square root function, we have its own inverse, which is squaring, right? So to undo a cosine function or a tangent function or a sine function, they should each have their own unique inverse. Cosine's inverse is inverse cosine. We kind of write it as cos with a little -1. And so if I take the inverse of cosine on the left side, then I need to take the inverse of cosine of the right side. So inverse cosine is going to undo the cosine. And so this will get x just by itself. So x is equal to the inverse cosine of 0.87. And I'm going to type that into my calculator by hitting, so the cosine, above the cosine is inverse cosine. And actually you have that for sine and tangent too. So to get that button, you're going to hit shift or second, depending on if you have the Casio or the TI. Casios, you'll do shift cosine. TIs, you'll do second cosine. And then 0.87. And I'm getting, for my angle, or for my side, I'm getting, for my angle, I'm getting 29.5 degrees, right? So I was solving for the angle x. So x is 29.5 degrees. We'll do our angles to the nearest tenth for simplicity here. I just want to double check on that one and make sure that I rounded that correctly because I didn't pay too close of attention, but I did, so that's good. Okay, let's do two more examples where we're solving for that missing angle. Okay, but now we're going to have to set up those ratios again. So I'm setting up the ratio for this angle. So in relation to this angle, I need to figure out which trig function I'm going to use by labeling the sides. So it looks like I have the opposite side labeled, and I have across from the 90 degrees, which is considered the hypotenuse. So the trig function that relates the opposite and the hypotenuse is the sine function. So sine of my question mark, right, that's labeled with a question mark, is going to be equal to the opposite side, which is 32, over the hypotenuse side, which is 40. I could divide that out, but I really don't need to know what decimal it is. Okay? What I do need to do, though, is I need to undo sine. So on the left-hand side, I'm going to do inverse of sine. On the right-hand side, I'm going to do inverse of sine. And so what's going to happen is the inverse sine is going to undo sine on the left. And so I'm going to be left with just my question mark. And my question mark is going to be inverse sine of 32 over 40. And I'm going to type that into my calculator, shift sign for the Casio, second sign for the TI. This one I want to make sure that I actually do wrap this in. On the Casios, we're going to be picky about this. On the TIs, it's going to open up the parentheses for you. Okay, so on the Casios, it doesn't. So I got to make sure I type in the parentheses, 32 divided by 40. Otherwise, it'll just do 32 and then divide by 40 afterwards, and then I'll get an error. So make sure that you wrap the 32 divided by 40 in parentheses there. And so my angle is equal to 53.1 degrees. All right, we have a little bit of time before that 15-minute mark, so let's do one more together. Okay, let's take a look at this. This one, I've got a question mark, and it looks like I've got the side next to that question mark label, which would be the adjacent side, and I've got the hypotenuse labeled. So the trig function that relates the adjacent and the hypotenuse side is cosine. So cosine of my question mark is going to equal the adjacent side, which is 24, over the hypotenuse side, which is 25. Again, I want to undo cosine, so I'm going to use that inverse to get rid of the word cosine. So I'll do inverse cosine of both sides. And so here we go, the cosine's gone now, and so the question mark is going to be equal to the inverse cosine of 24 over 25. Type that in my calculator. I'm going to hit shift cosine, wrap this in parentheses, 24 divided by 25, and press execute. So my angle is 16.3 degrees. Okay, that's it for new notes. We're going to go ahead and let you practice now.